The agenda today is going to include what is self-service, what does self-service look like, and how we going to solve that with a semantic layer, and how do we going to have composable metrics in a self-service layer, self-service semantic layer. Okay. Okay, so let's see a world without self-service first. So let's imagine that you're Bob, a data analyst working for a food delivery platform called Grab. Though I guess you don't have to imagine the second part. Okay, so one day, you as a data analyst, right? So you go to work and you are tasked with answering questions from the business people, and this is one of the business people. You want to ask some questions. So this guy's Adam. He wants to ask for the number of sales in the recent quarters. And so blocking is easy. So he goes straight to writing a SQL query for that. And the SQL query is pretty simple. So an ordering platform online going to have a order item table, right? An order item table is the line item in an order. And then the order item is going to contain a primary key, a reference to product. And then the product does contain the price. So to calculate the sales by quarter, we got to write a very simple query. Obviously, very simplified for the purpose of the talk. But we're gonna join from order items to product to orders, and then you're gonna calculate the sales by multiply the quantity on the order items by the product price, and then do an aggregation on top of that, and then group by quarter of order created at. This is pretty simple, pretty easy, but this is not what Adam wants. He actually wants to have it by product name. So Bob thinks that's okay as well, but he has to go back and write the whole thing again, but this time change the product name, change the data to product name, right? But that is still not what Adam wants. He wants to have the sales by both quarter and the product name. So you can see there's a lot of back and forth here. And okay, so there's a lot of back and forth here. So this is the final sequence. But this is not really, easy. It's easy work for Bob, but it's not very fulfilling work, right? As a data analyst or a data engineer, you want to work on the more fulfilling part of your job, like optimizing the data pipeline that you got before, or doing some machine learning or something like that. But he can't be bothered by business people to answer questions that are simple but are very intensive. So that leads to an unhappy analyst, and an unhappy analyst is very bad to keep around. Sorry about the language. Yeah, so this is a problem without self-service. Without self-service, your analyst is the service. Right? So your analyst had to be an answering bot, but not an actual engineer at all. So to solve this, we must somehow have a way for Adam to answer this question on his own. And this is the problem that semantic layer seek out to solve. So semantic layer for self-service. Okay, so semantic layer started with a very simple question. Can we teach business people to assemble pre-built SQL pieces without having to bother data teams with easy but repetitive stuff? This is the crux of the problem and the questions that semantic layer seek out to solve. But what is a semantic layer? So I asked ChatGPT or Gemini about it, and it gave me this answer. So a semantic layer is a business-friendly abstraction layer that sits between complex data sources and the end user, translating, so on and so forth. You can see that this is very high level, right? High level and very, talking more about the problem than what actually semantic layer is. Then what is a semantic layer? Okay, I have a very simple understanding about our mental model about semantic layer. A semantic layer is just a collection of table which we have before, like other items, product, other user, and then we have some join condition between those tables, and then we have the aggregation expressions which we call metrics, and then we have the grouping columns like year status, like user cohort, like product A, and we call those dimensions or attributes. What does this look like to you? What also have table, also have join between table, also have aggregation expressions, and also have grouping. It is a query. Yeah. So to me, a semantic layer in its most simplistic form is a query. It's just a query. So a query can contain the grouping columns, all the possible grouping columns, all the aggregation expression, all the table, and all the table pre-join. And this is a semantic model without any abstraction on top of it in its most bare-bone form. And this is already useful enough without any abstraction. Yeah. So without any abstraction, Bob can simply take this query and give it to Adam, and then teach him to use this query with some documentation, with no abstraction at all. Like if Adam wants to ask the yearly revenue number, he can simply take that previous query and then like comment out every part that he don't want and just keep the part that he wants, right? So to calculate the yearly revenue number, he just has to give the date of year auto created ad and the aggregation expression for the revenue, and all the joins doesn't have to be modified at all, right? Because it's pretty fixed, so he doesn't have to change that. Or if he wants to see by order revenue by status, then he just do the same, but this time swapping the datum to the status on the status, and he has that answer as well. Okay. And then lifetime total user, then same characteristic of user, ignore everything and any other part. So with this most simple form of a semantic layer without any abstraction, Adam already has a very simple form of self-service where he can answer the questions that he wants by himself without bothering Bob with any bothering insight. But it's not the most easy to use and the most having the best user experience. So we sorry. So we usually gonna do some abstraction on top of that query. So we're gonna take out the data here and put it in some form like a YAML like in DBT metrics or like here it's AML in Holistics. And then we take the aggregation expression, put it in a measure definition. The table we're gonna put in a model like DBT model. The relationship is the same, something like that. And with this, we're gonna have a lot of benefits. With this semantic model abstraction, business people can self-serve, right? Like I mentioned before. And then they don't have to write SQL, and there's no bomb in the middle, no bomb in the middle. And the BI tool that built on top of the semantic layer can leverage the semantic understanding to implement features, interactive feature. Sorry, somehow the video. Sorry about that, but there's supposed to be a video here, and it's gonna show the feature of like a left sidebar with some drag and drop interface to choose the dimensions and the measure, and then put it to create a visualization, and then you can create a dashboard, and then on that dashboard you can right click interactively to change the grouping from one dimension to another dimension. So you can have a really long bar chart, right? And then you can click on one of the bar to view the metrics inside that bar break down by another dimension. Okay, I think we can move on. Okay, is that the end? Oh, oh, maybe the link is on the CDN top. Okay. So okay. So is that the end? Is that the end? Now Bob is happy because you don't have to work. And then Adam is happy because he can answer his question on his own. So happily ever after, the end? Not really. Okay. The problem is that, business people, right? Business people are the type that are never satisfied. Sorry for any business people here. Okay. Once they can answer simple questions, they will ask for more complex questions. So let's see some of those complex questions. Okay. So now see it's very long questions, right? So the revenue from top five supplier for each product category based on total sales last year. You can ignore that, but for each year, list the median total revenue by products. So just by the length alone, you can see that these type of questions are more complex than the kind of questions that we had before, where we have a simple metric and we slide it by some other dimension. Here we have multiple layer of the query. Okay, can we answer those complex questions with the simplistic semantic layer like before? Can we answer those questions with this query? Not really, right? But let's see one of the questions. So for each year, what is the median revenue by products? The wording is kind of hard to understand, and the table doesn't really provide any meaningful thing at all. But you can see that we have a table with the product created at. What it is the product of the order created at. And we have a metric that calculates the median revenue for each of the products that was ordered in that quarter. Okay, can you wrap your head around that metric? Okay, so how can we solve this? Okay, so I asked ChatGPT about this. And this is the answer that it gives. It's a simple query, really. So there are two stages of the answer. First, we have to calculate the revenue by product. Next. Okay, revenue by products. But we have to add the date term on year as well, because we want to the original questions for each year, right? So we have to add the year into the CD as well. So now we have two stages, one with revenue group by year and product ID, and then we have another aggregation outside that use this CD table and then calculate median. So not a hard SQL query at all, but can we fit this into our semantic layer abstraction? How do we do that? Anybody here can think of the way? How can we fit this into our semantic layer abstraction with metric, table, joins, and grouping? Okay, so a CTE return a table, right? So we often think that we would do this by taking the CTE outside into SQL modeling, right? So we would take this, the CTE, and put it in a DBT model or a view or something like that. And then we would only expose the table to the semantic layer, and then we build a metric on top of that. So here is the step, right? We create the view there, and then we take the table and put it in the semantic layer, and then we take that table and then we calculate the median on top of that table. So we have a metric. But does this metric work? Kind of. But we have a problem. Once a view or a DBT model or a materialized table is created, it's not possible to change the grouping on the file. What does that mean? Okay. So Adam don't want to see this Adam guy again, right? But Adam don't want to see the median by year. He wants to see it by month. So now Bob has to go back to the SQL query and change the year to month, right? And then he has to update the view and update the metrics. And then what if like Adam wants to see it? Okay, next slide. Yeah, so this, right? Have to do this again. And then what if he wants to see the median by user cohort? The cohort is the year that the user has the first order or first half. Just think about it like that. Then he would have to do the same, but this time change the year from order field to add to user cohort. And he cannot fit all of these three dimensions into the same view, because if he put cohort and year order into the same view, then the revenue would be break down by both the cohort and the month and the year. And then when we calculate the median, it wouldn't be right at all, right? Because the granularity is completely different. And then, so with just one question, we have 3 tables and 3 metrics, right? And we have to think more than that. What about the combination? This is a very, like simple math, but like if we have like a 10 table and 10 dimensions per average, then the number of combination would be astronomical. Obviously, Adam can probably think like 20 of these combinations, not this much. But you can see that this is not scalable at all. With any variations of the questions, user has to go back to Bob again. So no longer have self-serve. So self-serve is dead. Yeah. So yeah, see, so metric doesn't work with any dimension. Manual SQL is needed, and these people cannot self-serve. So how can we fix this? Is there another way? Oh, sorry. And this is just abandoning semantic layer with extra step, right? Is there another way? So at Holistics, we have faced this problem. This is not a hypothetical to us at all. So our user at first are very happy with the semantic layer that we have, but as they mature, they found out that the questions that user asked is very complex, and the very simplistic semantic model that we have before cannot self-serve those questions. So we have to think about the approach. So what is it? Okay, what if instead of having to do this dance where when you have a complex metric, you take the whole logic and put all of that logic into SQL modeling and only expose a very rigid table to the semantic layer where the semantic layer has no control over. What if we can do this? Why does we have to do the dance like before? Right? Isn't it because we think that semantic layer cannot do this logic, cannot handle this logic by itself? We cannot put the whole logic of calculating a metric into a metric itself for it to calculate itself, and we have to do some workaround by moving the logic outside of the semantic model. But if we can encapsulate everything into the metric itself. So in order to do that, the metric must first, it must be able to be a full query. It must be able to create multiple stage of a calculation where it can, like calculate some median by product ID first, and then, calculate the revenue by product ID first, and then do the median later. And then it must understand that understand the context where it was used, so that it can reactively change the logic of itself by injecting the dimensions that the user are using into the SQL that it generates. It must be able to do that. So is this possible with SQL? Not that I know of. Because SQL metric in most semantic layer out there, like DBT metrics, or even something like Looker, are snippet. They can only contain things that are valid in an aggregation expression right there. So only things that are valid there. So they can return table. They can have nested query. Technically you can, but it's not very practical to run a query on every row of a query, a nested query inside, you see. So, and it has no concept of dimensions for injection. So it's not possible with SQL metric. And we will need a new language. Let's just imagine first, what if we have a language that can define something like this, where we define a metric, like revenue per product, that calculates the revenue for each product ID and return that table inside a cell. So when we run the revenue by product metrics, it's going to return the table that contains every revenue of every product in a cell, in a single cell. Not return the table, but the nested table in the cell. And then, when we add the quarter create add, it would do the thing that we have to do manually by hand for in SQL publishing, by injecting the dimensions that we are using into the SQL that is generated to, to change the grouping of the revenue per product table from no grouping at all into quarter of order created at. So the table here returns for every row. For every row, it's going to return the quarter of the order, and then it's going to return the revenue by product for each order. For each product in that quarter, each row. So each row here is a table. See? So and now the calculate median part is easy. We just create another metric to calculate the median on top of the table that each row returns. Easy, right? So 265 is the median of the sixth number in 44. You can calculate that, taking 216 plus 314 divided by 2, because there are 6 numbers, so the median is going to be between those. Okay, so next. And with that, you can have a metric that is truly flexible, truly reusable with any dimensions. Any of the dimensions on the left side bar here now can work with the metrics. You don't have to do any extra work to have it working. And user can self-serve and answer questions like product by year, product by user cohort, and combinations like user cohort and the continent. It's so easy, right? For the business user. That is the language that we at Holistics has developed for our user to solve this problem. And it's a language called AQL, Analytics Query Language, a language designed for composable metrics. A metric in AQL deliver on the promise before, where a metric in AQL are a full query. It's not a SQL snippet. It can leverage everything a query can have. It can have nested ad hoc table. It can have nested grouping. It can have window functions. it can have its own web box, and it is reactive to change in dimensions in the outer context. Okay, and the example I showed you before is real AQL. Obviously, the syntax is a bit different. So revenue by product is going to be the product table, group by the product ID, and then we select the revenue out of that table, and then this table is returned in this metric. Median just calculate on the table that the previous metric returned. Okay, but this is just one piece of the problem, right? We have solved a category of problem we call asset grouping, but there are many more category of problems. And so for the other type of questions, let's look at one of them. Top 5 supplier previous. Top 5 supplier for each product category based on the total sales for last year. So there are two things in the questions here. One is the top 5, the ranking, right? So we need with a function. And then one is last year, so our metric must understand time. How can we solve these two parts of the problem? Okay, so for window function. Window AQL obviously support window function, but window function in AQL are even better than SQL. So you can see this two table, right? So one is the table for ranking of year with the most sales in a continent. So America gonna have like these 4 with the most sales, and Asia gonna have these 4 years. And then a table for merchant with the most sales in a continent. So the merchant for America also have 4 merchants that are very highly profitable, Asia the same. So you will think that without AQL, you will think that these two are two very different methods. Right? One is calculating a ranking for year, one is calculating a ranking for merchant. But to AQL, this is the same metric. It is the metric of rank of revenue by each continent, regardless of what we are ranking. We are ranking revenue by in each continent, regardless of what are those things in the continent. So metric in AQL, window function in AQL, understand that when you drag year create add-in, you are calculating the ranking of year in the continent. And when you drag merchant in, you understand that you are calculating the ranking of merchant with a single metric definition, and you don't have to change anything at all. Okay. And what about tab? Like previous one has a clause where compared to last year. So here we have a table that calculate the year within each continent, and with one column for the revenue of this year and one column for the revenue for last year. So that can be calculated in AQL. With this, can you see that? Okay, it's a bit low, little bit low, but okay, but it's revenue, and then there's a function with auto created as shifted back by 1 year. And with that, you can have this table with metric that was used for this table. But the even better part is that metric in AQL intuitively understand time, so that when we change the year to quarter, the metric gonna change from being a metric that compare year by year to a metric that compare this quarter to the same quarter last year, without having you to do anything. You just click on the UI and change the year to quarter, and how it will be like this. So with that, you have to do self-join, date shifting, or things like that. You can have a metric that is very flexible. Okay, there's more features, but I think for the time, I'm gonna just move on. So we can change group by, we can cover semi-additive metrics, we can do a lot more things, like these things, or more things as well. And so with AQL, Bob has everything to answer all of the hard questions that he can. So it's cover everything the SQL can provide, and also offer the flexibility of building a better metric language for Adam to use, so that the metric is both reusable, flexible, and can serve self-serve as best as possible. Okay, humorously, Bob can sleep now after doing his work, and Adam can avoid being knifed by his college. Okay, so summary. A semantic layer allows business users to do self-service analytics without writing SQL. But a SQL-based metrics semantic layer has limitations that prevent end user from asking more complex data questions. And to fix that, we need a metric layer abstraction with a better language to define metrics that are truly flexible, truly composable, and truly serve for self-service. And that is what the end of the talk. If you want to learn more about AQL or Holistics, you can read the link here. And the Q&A session at the end, and then to the Q&A session. Okay.